So you've worked your way up to building your first robot. There are 3 types of motors that you'll encounter as a maker, and they've all got their different strengths. So the first and most simple one is a DC motor. This one simply takes voltage in one direction or another, and that determines the way that the motor spins. So if I hook up this red wire to voltage and this black one to ground, I'm going to get the motor to spin one way. But if I hook them up in the other direction, it'll spin the other way. It's very simple, and it operates on switching electromagnets that move between permanent magnets. How do they work? A question for another day. You've seen this type of motor as a PC fan, probably, i.e. the thing that's currently freaking out on my computer, as well as motors for really simple robots. Then you've got servos. These are popular in robot arms and humanoids and other things that require precise angular control. Delta robots will typically have 2 of these to move each of their 3 arms, and then they can control a moving platform very precisely in 3D space using something called inverse kinematics. Anyway, this guy can be sent to a particular angle using a data line. So if you just give it voltage, it's not going to do anything. But once you start sending it a signal, you can say usually somewhere between 0 and 180 degrees. Actual servos will probably have limits somewhere within that, say from 10 to 165 degrees or something like that. So if your servo is making a little grinding noise, make sure to calibrate your program so you don't go beyond that. It's useful to set that as a constant variable so that when you swap things out, it'll still work. These come with different little attachments usually, so there may be a little screw to hold it on, but then you can swap out the heads for something circular, or a couple of arms, and things like that. As with other motors, try not to twist these manually, because it puts wear on the motor. You can get eeny-weeny micro servos all the way up to big, beefy dynamixels, which are popular for humanoid robots, which take a lot of torque. There are also continuously rotatable servos, which will go around and around and around and around with no problem, but still have precise positioning. Servos will have 3 wires going to them, that's voltage, ground, and data. And finally, we've got steppers. Stepper motors have about a bajillion wires coming off of them, somewhere between 4 and 6. They typically come with a plain shaft, and you'll need a driver circuit to control these. This one, for example, comes with a seed grove kit, and they include a little connector so that you can hook it up. These ones are often used in CNC devices, computer-controlled machines like 3D printers, laser cutters, and other machines. They're called steppers because they move in very precise steps. They have more magnets and brushes than regular motors, and they're triggered in synchronized phases, which is why they require this complex driver circuit. But that gives you very precise control with continuous rotation, which is great for telling machines to do stuff in a very specific way. You'll often see them used to control threaded rods, which move things up and down or side to side, or timing belts, which are stretched between the motor and another point, and have little teeth to latch onto the motor. We'll be covering all of these in depth, so stick around.